And by the way, all the photos in these presentations this afternoon are my own, most of them are, and it was when I was walking around Christchurch in 2019 and 2020 and 2021, still looking at the damage from the 2011 earthquake. And it's a great place to go if you want to see the results or the effects of earthquakes on buildings. Right, so the contents for the first half is, well, why is it so hard? We'll go through it step by step. We'll talk about the IEP. What the hell is a CENT NBS rating? We'll talk about responsibilities in the law, and this is really aimed at clients. Those clients are your customers. We'll talk about seismic grade and life safety. What does it mean? And how risky are your buildings? We'll then look at DSAs, that's detailed seismic assessments. They may or may not be required. And we'll look at a flow chart for occupancy assessment, because that was something I made up when I was asked to do it. And we'll get to that later. And a brief look at the guidelines and what are the issues. So the first question is, why is it so hard? You could ask the same about your degree, I guess, and all your studies now. Why is it so hard? Because it's damn complicated. And doubly so when you're talking about earthquakes. Now, most people can understand that when a load goes on a beam, gravity loads push the beam down. What you've got to think about is that when you've got earthquake loads on a building, gravity kind of moves around. You've got gravity acting, or the equivalent of gravity acting, in all directions, about 6 degrees of freedom, in many different directions, all at once, back and forth. And the forces that they generate in your building are very, very complicated. So it's not easy to put them into a simplified design method. And I'm guessing you might have done response spectrum, things like that, because that's what you end up doing in multi-story frames. Oh yeah, and New Zealand takes a different approach. Because of course it does, because New Zealand is unique. It's a special place in the world. And in case you didn't realise, we are slap bang on that ring of fire. And it's where the Australasian plate meets the Pacific plate. And it's been, the Australia are dragging us down. So the Australian plate is pushing against the Pacific plate. And it's dragging down, dragging down, dragging down. And that intersection is in our nation's capital. It's in Wellington where those two meet. If you drive down Highway 1, State Highway 1, you drive into Wellington, you'll notice a cliff down there. That is the fault. And I say the fault, it's the fault. It is between two primary tectonic plates. And so naturally, you would put your capital there, wouldn't you? An earthquake-prone area. And at one day, it's going to go down, 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 and one day it's going to let go. And the beehive is going to go down. Which is a bit of a pity, because they have spent millions of dollars doing a seismic upgrade on the Parliament buildings. And it's great for earthquakes that do that, side to side. And most earthquakes do that. The vast majority of earthquakes around the world do horizontal motion. That's the primary means. The big one in New Zealand, it's going to be in Wellington on that fault when the fault lets go. If you're lucky, it'll go bit by bit by bit, so it won't be so bad. If we're not so lucky, Wellington's going to be flattened by that. Not to put you off. So step by step, we start with an initial seismic assessment, or ISA, and that uses the initial evaluation procedure. Don't you just love all these acronyms? IEP, and people will phone up as we're engineers. We need an IEP. They haven't really got a clue what it's about. That really is the subject of the second half of this seminar. We use an IEP, then we also use a desk study. So let's look at what information is available. And primary information is from the council property file. With a bit of luck, they'll have some drawings, plans for the building, and you may be able to see the structure. Chances are they won't, and your council property file is full of licenses for alcohol. That's what they keep. You'll do a survey, a structural survey for an initial seismic assessment. The survey is non-intrusive, although you could take some ceiling tiles. You don't start smashing it to bits, taking samples or cores. Not yet, anyway. If needed, you then do a detailed seismic assessment and you do a much more thorough structural inspection and particular aspects. So you'll find out what the critical structural weaknesses are and you want to reveal them, which might mean taking samples, opening up works, revealing the structure. Because unfortunately, in most buildings, the structure is hidden. It's hidden behind cladding, behind walls, behind ceilings. If you've got a modern office block with removable tiles, you don't have them here, but many office blocks have removable tiles, so it's easy to get into them. If you don't, you need to cut it out, which there's a cost to that and a cost to repair, which the client needs to be informed about. You also need to do a geotechnical investigation, or at least commission one, and that finds out what the geotechnical parameters are. And then you might look at seismic strengthening options and then do the seismic strengthening design if you wish, or if the client wishes. So again, an example in Christchurch, what is the initial valuation procedures? So it's the start of the process of doing a seismic assessment of an existing building. And what it does, it signs a percentage NBS. NBS stands for New Build Standard. Keep up with these acronyms. And it gives you a rating and a grade associated with your building. And it enables your building owners and building managers to review their building stock. So I own a building, I want to know what state it is. Quite often it's usually a new owner or a potential buyer who's been driven either by the insurance company or the bank to get a seismic assessment. And that will either determine whether they can have a loan for the building or get insurance for the building. And if you can't get insurance for your building, you won't get a mortgage for it. So what does it mean? Well, we're assessing the capability of a building to resist an earthquake, but it's not the full whack that we put on a new building. And we compare it against the loading requirements of our standard, a new building standard 1170, part 5. So it's just an indication of how it's going to perform against a similar earthquake. So if you've got a new building and you've designed it correctly and it's been constructed properly, you can have an NBS well in excess of 100%. And you would expect that largely for other reasons and for basic requirements of the codes. Modern codes of practice require your buildings to be robust. And so you can avoid disproportionate collapse. So what about the law? There is, at the top of the tree, the Building Act 2004, which basically says, make sure your building stands up and doesn't kill anybody. There's an amendment, 2016, which is about earthquake-prone buildings, and this is where all this assessment comes from. So it sets out a framework for identifying the earthquake-prone buildings. So it's not you, it's the technical authority in that region, sorry, the territorial authority in that region, who must identify the earthquake-prone buildings in that region. And Auckland, the territorial authority is Auckland Council, and in many regions, the territorial authority is the local council, but some of them are overlapping, so you need to check. If they suspect that a building is earthquake-prone, they need to inform the building owner. And the building owner then has to get an assessment, which usually means engaging an engineer, and tell the council or the territorial authority what they're going to do about it. If the assessment comes back that it's got a percentage NBS less than 34%, then the engineer informs the building owner, who then informs the territorial authority that it's 34%. The territorial authority may say, that looks like an earthquake-prone building, and we may need to put it on the earthquake-prone buildings list and have a nice plaque on your building that says, this is an earthquake-prone building, but don't panic. So the owner of the building is responsible for ensuring compliance with any notices to fix. So the council can tell you to fix your building. Unfortunately, there's quite a long period of allowance as to when you can fix your building, when you have to fix your building. At the moment, there's no legal requirement for a building owner or a building purchaser to get an IEP. They don't have to employ us. But it's usually, as I say, the bank or the insurance company that puts the onus on the owner to get the IEP. If you're going to alter a building, so quite often owners will buy a building with a view to refurbishing it, extending it, modifying it, putting another floor, change its use. The simple rule is it's got to be as good as it was before the alteration. There's another fact, if you put new work in it, that's got to comply with the new standard, the latest standard. So what does it mean to be earthquake prone? So an EPB is given, assigned, or chosen when your earthquake prone building may have issues under an earthquake. And you say that when the building or part will have its ultimate capacity exceeded in a moderate earthquake. And if the building or part were to collapse, the collapse would likely cause injury or death to persons in or near the building or to any other property, or damage to any other property. We'll come back to that. So what do we mean by a moderate earthquake? Well, it's not the full whack that would give it to 1170.5. So for most normal buildings, we're looking at a return period of 500 years. So it's a 1 in 500 year event for most ordinary buildings. If you've got a more important building, importance level 3 and 4 and so on, the requirement is for a much longer return period. So a moderate earthquake is about a third as strong as one would expect for a new building. So you're given a seismic grade that translates into a risk. So if your building is A+, you've got more than 100% NBS, you're good to go. You've got a low risk building. If it's seismic grade D and E, which means you've got somewhere between 20 and 33% NBS, then you're looking at high risk or a very high risk. So what does that mean? Well, if it's a very high risk, the risk to life safety is 25 times higher than it would be for a new building, which sounds kind of scary, but you've got to bear in mind what level of risk you're exposing yourself to in a modern building and work back from that. So if your modern building risk is 1 in a million or 1 in 10 million, you've got to work it back from that. This is the timetable for how to repair the building, or when you've got to repair the building. So territorial authorities should have already identified all the earthquake-prone buildings in the high-risk area. Dear old Auckland's got till 2032 to identify all the earthquake-prone risk buildings. And once they've been identified, the owner has between 7.5 and 35 years. So if you're in Wellington in a high-risk building, you need to get it fixed pretty soon. If you're in Auckland and you're identified as an earthquake-prone building, yeah, you'd probably put it off, won't you? 35 years. But as long as you tell your council you're going to do it within the 35 years, you're good to go. But what it does is it puts that building on the earthquake-prone building register, which will affect the sale of your property. So when you purchase a property, you'll do searches, legal searches, and the legal searches will pull up your building is earthquake prone. That means it's less valuable than one that isn't. Those are the high risk areas. You can see the high risk areas run basically straddling the fault. And up here in Auckland, we're in a low zone. And when we say low, this is relative. This is relative to the rest of New Zealand. So we're not the big red scary bit down in Wellington or on the Cook Strait. No. We're out here. But it's still a higher risk of earthquake and a higher earthquake than most of Europe and a good deal of North America. So here's one I prepared earlier. What do we mean? So a lot of people don't understand risk. The general public don't understand risk, but you're engineers, so you should be good with numbers. You should be good with probability, and you should be good with risk. What does it mean? So here we have in the middle, If your building is 100% rated, 100% NBS, then it's going to perform pretty well in a typical earthquake, a design level event. That's defined in the code 1170 part 5. Moving down the scale, if it's less than 34%, and this is a fairly arbitrary number, you're going to be an earthquake-prone building. And anything above a moderate earthquake, that's about a third as strong as a design level event, then you're probably going to be in trouble. In between times, you've got this thing called an earthquake risk building. Legally, you only need to improve your building to be bigger than 34% NBS. To me, that's nuts, but that's what the law says, and that's what the council and territorial authorities will require. You just need to be out of that zone. Most clients, being slightly sensible, want to be out of the earthquake risk area, and it's a bit of a selling point. My building has got an 80% NBS. There are certain councils and certain public bodies that will not occupy a building at less than 80% NBS. And, because that's tied into employment law. And under employment law, your employer has to guarantee or provide you with a safe working environment. And so if your building is earthquake prone, it could be argued that your building is not a safe working environment. And you could, as an employer, be liable to that. And so public bodies tend to take that a little bit more seriously. So how risky are they? So the territorial authority will tell you if your building's an earthquake-prone building. It's not the engineer. The engineer tells the client tells and passes that on to the territorial authority. And the territorial authority will say, oh, yes, that's going to be an earthquake-prone building. If it suspects that it is, it needs to tell the owner, get an assessment and act on the assessment. So generally, and it's a pretty sure thing that the territorial authority will say you've got an earthquake-prone building if your rating is less than 34%. So it's a risk to the occupants, so between 10 and 25 times that of an equivalent new build, which just meets the minimum requirements for life safety in the New Zealand Building Code. Remember, codes are minimum requirements. They're not optimum requirements, they're not luxury requirements, they are the minimum requirements for a building. You expect most buildings to exceed them, and you expect buildings to have an adequate margin of safety. We'll come to that in a moment. However, you need to put that into context. In the context of seismic risk, compare it to the risk of a new build. So what we tend to say is the risk to life safety, i.e. fatality, of 1 in a million is possibly acceptable. So it's a very low level of risk. This is similar to the risk of death by lightning strike. And the risk of death by lightning strike actually varies around the world, by the way, and it seems to be quite high in New Zealand. Just saying. Yeah, so it's quite a small risk, really, when you can think about it, but people do panic. When you do a structural inspection, you'll get your client who looks a bit like that. And for those of you who don't know, that is Laurence Olivier in the film Marathon Man. And he was torturing Dustin Hoffman and asking the question, is it safe? Now, when we have a client who's commissioned you to do a structural survey of your building, he'll come back after you've done your survey and say, is it safe? And you go, well, what do you mean? What do you mean? What do we mean when it's safe? Because it's never really a black and white issue. Clients think it is. It's either safe or it's not safe. In reality, it's somewhere in between. And that's why we like to think between the safe and the unsafe is a margin of safety. And we like to have an adequate margin of safety. So when we report, we can say it has a reduced margin of safety or even an inadequate margin of safety. So how risky do we tolerate? Yeah, that's good. Big picture. This is something I did in lockdown, just for shits and giggles, I guess. And it was pretty obvious in lockdown, nobody had a clue about risk. What's it mean? What do we tolerate as risk, our risky activities? Rule number one, there is no risk-free life. You cannot have a risk-free life. There is risks to everything you do every day. And one of the most dangerous things you do every day is get in the car and drive, particularly with New Zealand drivers. Here is some examples from the UK about assessing risks. They like to put numbers to it because it looks scientific. So on the left, we have the high hazard industry processes. So if you're refining oil or creating chemicals, your factory needs to get the risk down to below 1 in a million, and that's considered broadly acceptable for the high hazard industries. On the right, we have, well, there's the transport of hazardous materials. So if you're driving a truck full of chemicals, what's the risk to the outside world? How likely are you to kill people? And the more people you kill, the lower probability you want, or the higher lower risk you'll accept. And we have this thing in between. So if you're looking at one fatality, 1 in 10,000 there, 1 in 10,000 for transporting hazardous materials is considered an acceptable risk, one fatality in 10,000. If it's 1 in 10 for one, that's considered intolerable. In between, we have this kind of green zone where we need to do a little bit more analysis, and we call it the ALARP zone in the UK. ALARP means as low as reasonably practical. So you can't eliminate all risks, but you can get them to be as low as reasonably practical. In New Zealand, we talk about ANARP, as near as reasonably practical. Same sort of concept in there. So are all buildings less than 34%? Are they earthquake prone? Probably. It doesn't mean it's dangerous or it poses an imminent risk. Now, some buildings will pose an imminent risk and you need to do something about it, but probably for other reasons. So if it can't take its gravity loads or wind loads, you need to shut the building down or take precautions to get it fixed. Decisions about the continued occupancy of a low-rated building are the responsibility of the owner and the tenants. However, the owner will rely on you as the engineer to inform them. They need to make an informed decision as to how risky it is. It's not an absolute assessment. It's pretty quick and dirty to get a rough idea of the risk. Doesn't mean it's posing an imminent risk or that it's going to collapse. However, it does pose a higher risk than normal during an earthquake. NBS, or percent NBS, is about the performance of the building in protecting people's lives. It's not about how the building will potentially stay intact. So in an earthquake-prone building or even an earthquake risk building is likely to be damaged, and in some cases damaged beyond repair. But a lot of clients don't know that. That's why there's now a drive on to look at low damage earthquake design. It's about protecting people's lives and other people's property. So if your building falls on another property, it can be an earthquake-prone building. Doesn't say anything about the damage to your building. If you've got a higher rating, doesn't mean it won't collapse, but there's a higher probability that people will get out in the event of an earthquake unharmed. Would a DSA, will it be required? Yes. If you've got a percentage NBS less than 34%, we'd always recommend doing a DSA. If it's below 67%, we'd recommend doing a DSA because your ISA is quick and dirty. The DSA is a lot more detailed. So ISA is qualitative. This is where the art comes in the engineering. You are assessing it. You're not doing lots of numbers. You're looking at the qualitative assessment of the building, usually from a non-intrusive survey. So if it's non-intrusive, it's going to be quite limited. You can only inspect what you can see. You can only report on what you can inspect. A DSA, on the other hand, is a quantitative assessment. You will do calculations, you will crunch the numbers, and you will do a more detailed investigation and even testing in some cases. You can take samples of the steel or samples of the concrete And by that, you can get the actual material properties that the building has. That's one of the issues with DSAs, is working out what the strength of the materials was when it was built maybe 30, 40, 50 years ago, and they haven't kept the records. Now, things have changed in those past 40, 50 years. Materials are not the same as they used to be. Steel today is a lot stronger than it used to be. It's not necessarily stronger, it's just more reliably stronger than it used to be. Timber, on the other hand, is weaker than it used to be. Interesting. So the DSA, we want a more precise NBS. We want to find the structural elements that are weak. We might look at strengthening. So if you crunch the numbers, you might get it out of the earthquake-prone building status. Maybe. You might make it worse, because you might find even more horrors. And then you can talk about strengthening options. NZSEE, the earthquake people say, you better do it to 67, even though the legal requirement is only 34. Why would you strengthen a building only to 1/3 as strong as it should be? Hey. Yeah, so it should be an important consideration. So for many, many years, building owners didn't care about the building performance in an earthquake. The building was standing up, what's the problem? Well, until an earthquake comes along, that's the problem. If you're a client, having that knowledge puts you in a more powerful position, i.e. it's a selling point. If you don't know, there is that grey area. And if it's already marked as, well, it's earthquake prone, that's going to put off buyers. But it does help you understand what you need to do in the future. You might rearrange the building, you might redo the structure, strengthen the structure. Yeah, tenants' demand, particularly from the public sector, is demanding NBSs above 67% anyway or more as a condition of their lease. The seismic strengthening, so building owners are responsible for any work they do to the building and to make sure it complies with the New Zealand building code. That's quite a lot to put on a building owner. That's why they employ us, to find out how to strengthen their building, to get it up to the adequate level. So you need to get building consent for your improvements, and to get building consent, you need to have code compliance of your design. So you'll do your calculations, you'll produce a statement on it, and your producer statement, well, it's you as a chartered engineer signing this off, say this strengthening work is adequate. And of course, it needs to be built by people who know what they're doing. Yeah, so the regulatory system sets out the framework for the design and construction of buildings in New Zealand. Many people in the building industry and in the construction industry don't really understand that. So a summary again, at the top of the tree is the Building Act of 2004, which basically says make sure your building stands up and doesn't fall down and kill anybody. You've already got the building regulations in effect, and the building code is derived from the Building Act. That sits below the Building Act, but above all the national standards. So it will say what kind of building you have. 2 minutes, oh my God. We're not going to get to part B. Right. Yeah. So the requirements in the Building Act, the Building Code, building regulations will determine how the building is built, designed and constructed. Yeah, gone through that. You can be at risk, of course, you will get sued if it goes wrong as an engineer. This is my little flow sheet, flow chart for making the decision as to whether your earthquake-prone building can be occupied, and you trickle down as to what your percentage NBS is. And ultimately you get down to, do you occupy it and it's okay? Do you occupy it with a limited occupancy, or do you just don't accept the risk to the occupancy in there? These are the parts of the guidelines. These are the seismic assessment guidelines for existing buildings. You really need to look at part A. That tells you the basic principles of it. Part B is about initial seismic assessments. All the rest are for detailed seismic assessments, material by material. So you've got concrete, steel, timber, and unreinforced masonry. You'll notice there is no code for unreinforced masonry in New Zealand because you're not allowed to build unreinforced masonry in New Zealand. Unfortunately, there are lots and lots of buildings in New Zealand that are made of unreinforced masonry, and they don't perform very well in an earthquake. They're performing very well in other aspects, but in an earthquake, not so good. So if you have a lot of masonry, unreinforced masonry in a building, it's likely to be earthquake prone. So finally, right, so ISA is quick and dirty, DSA is long and expensive, and seismic strengthening are, you don't know when you're going to get. So there's more. Part B is on the Daddy Pig YouTube channel, so it's there. Write that down. And if you're looking for any of the MathCAD sheets I showed this morning, they're available through the Daddy Pig website, which is bigpiglimited.com. Shameless plugs. Word from our sponsor, why not? Okay, thank you all.